All right, welcome to 4.7, day one. Today we're talking about the quadratic formula. How do you solve quadratic equations? By using the quadratic formula is our essential question. To warm up here, we're going to simplify these square roots. And basically when we look at a square root, we need to ask ourselves, can we break this into a number and a perfect square? So our perfect squares are over here, and they're the nice easy ones, like 4, 9, 16, 25, 36, etc. You know, this is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, on and on and on. And the reason being is because these are easy numbers to take a square root of. Okay, so if we look at 24, can we pull one of these numbers out? And the answer is yes. We can split this into the square root of 4 and this times the square root of 6. Okay, that gets us the square root of 24. The reason I did that is because 4 is a nice square root number. And so I know that the square root of 4 is 2, and the square root of 6 can just stay as is. And so that would be the simplified version. Okay, over here with 80, I need to ask myself, can I take anything out? And I do believe it is divisible by 16. Let me just double check that. 80 divided by 16. Yep. And so we can split this into the square root of 16 and the square root of 5. Okay, and they're multiplied together. Okay, now I know that the square root of 16 is 4, and the square root of 5 we just leave as the square root of 5. Okay. So, taking that knowledge into what we're doing today, if we go to solve this, we need to find factors of negative 7 that add up to 3. And if we do this, we get, really our only options are 1 and 7. But there's no way that we can get them to add up to be 3. And so the method we've been doing, it won't work. And so we're going to turn to the quadratic formula. The quadratic formula is this. There's a song with it. It's to the tune of "Pop Goes the Weasel." If you YouTube it, we're gonna sing it in class. You can YouTube it as well. It's an annoying song that just sticks with you, but man, is it helpful. So just get through the agony of having to listen to it and let it stick into your brain, and it'll help you out. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So I can't even really say the quadratic formula without kind of singing that song in my head because it's been drilled into my head for so long. So our quadratic equation, remember the number out in front of the x squared is the a, this number is the b, and then our constant is c. Okay, so we're just going to kind of plug in our numbers where they go into our equation, and then we'll be all right. So we have this quadratic, and we are going to use the quadratic formula to solve. All right, so I know that this is my a is 1, b is negative 3, and c is negative 10. Now remember to include your signs. Okay, it's important. Okay, so x equals negative b, so negative, and then our b is negative 3, plus or minus the square root of b squared, which is negative 3 squared. If you're using your calculator, make sure you get parentheses around that negative 3. Minus 4 times a, we know that a is 1, and c is negative 10. All over 2a, so 2 times 1. Okay, and then we just start to simplify this. So negative minus a negative 3, that becomes just positive 3. Plus or minus the square root of negative 3 squared is 9. Negative 4 times 1 times negative 10 would be positive 40. And then all over 2. Okay, now we continue to simplify here. 3 plus or minus the square root of 49 all over 2. And can I simplify this any further? Yes, I can, because the square root of 49 is 7. So 3 plus or minus the square root, 3 plus or minus 7, the square root of 49 is 7, all over 2. Okay, now I've gotten rid of the square roots and everything. Now I'm going to play two different scenarios here, because I have 3 plus 7 divided by 2 and 3 minus 7 divided by 2. And so those are my two answers. 3 plus 7 divided by 2. Okay, that equals 10 divided by 2, which equals 5. So one of my answers is 5. Okay, then the other scenario here, 3 minus 7 divided by 2, that gets us negative 4 over 2, which equals negative 2. And so my two answers are 5 and negative 2. All right, here we go again. Now, before I start, I need to get everything on the same side. So minus 4x, I'm going to subtract 21, and then I'll have equals 0. I need it to be all on the same side, just like yesterday. Okay, now x equals negative b plus or minus square root of b squared, so negative 4 squared, minus 4ac all over 2a. Okay, so this is 4 plus or minus the square root of 16, what is that, plus 84, all over 2. If we reduce that down, 4 plus or minus 16 plus 84, I believe is 100. Yep, it is. Yep, 100. All over 2, which equals 4. Now, the square root of 100 is 10. Okay, and now I can play my two different scenarios here. So 4 plus 10 divided by 2, and that equals 14 over 2, which equals 7. And then my other one here, 4 minus 10 divided by 2, that would be negative 6 divided by 2, which is negative 3. All right. Our next one here, we're going to up the difficulty level a little bit, because these two we could have solved with our old methods. We got nice easy numbers both times. Okay, but you're not always going to get that. Just like in that first example up here, there's no way we could get these to add up to 3. And so there will be times where that happens. And so here we have this one, 5x squared minus 2x minus 2 equals 0. Okay, I'm going to set up the problem, and then I'll be back. You set up the problem as well. Okay, so we're back. Hopefully you have what I have. You've set it up. I took the first step in simplifying it here. And so now we have 2 plus or minus the square root of 44 divided by 10. Okay, now this is why we warmed up with these types of problems, because the square root of 44 is not nice, but I can split it up, can't I? I can split it up into, I can split this into square root of 4, because that's a nice perfect square, and then square root of 11, which is not so perfect. Okay, and so I'm going to, I know that the square root of 4 is 2. So instead of writing square root of 44, I'm going to write 2 times the square root of 11 over 10. Okay, now I notice that here, here, and here, all 3 pieces are divisible by 2. So I can reduce all of them down, divide all by 2, okay, and we'll be left with 1 plus, no, we don't need to write this one, it's out in front, so we'll just say the square root of 11 over 5. Oops, I forgot my minus here, plus or minus the square root of 11. Now, I can't go a whole lot farther with that. This is sufficient. You don't need to turn it into a decimal. Just leave it like this. Okay, and now the last one, you set it up, I'll set it up, and then we'll meet back together. All right, and we're back. So I got this far, and hopefully you got close to this far as well. So when we continue to simplify, we get the square root of 228 over 14. Okay, now 228, I'm guessing that splits up into a perfect square somewhere along the line. 4 is a good possibility, so 228 divided by 4 gets us 57. Yeah, that's going to be our winner right there, because 57 is prime. No, 57 is not prime. Doesn't matter. It's not a good square root number. So we have square root of 57 right here. Okay. I believe that's all we can do. Okay, so I know that the square root of 4 is 2. And so when I continue to simplify this, it's going to be 4 plus or minus. Now I broke this up into 2 times the square root of 57. And then 14. Okay. Now if you notice, I have this is divisible. I can reduce that down, and I can reduce this down. So all 3 pieces are even, and so I can reduce them all down. So I would end up with, let's see, if I divide everything by 2 here, I would get 2 plus or minus, that would just be 1. So plus or minus the square root of 57. And then 14 divided by 2 is 7. That's as far as I can get, and that would be my answer. All right, that's 4.7, day 1.